Similar polygons. Getting right into it. Similar polygons are polygons with the same shape but different size. Okay? So imagine if I had a Statue of Liberty on my desk. It's not going to be the giant Statue of Liberty that's in New York, but it's going to be a similar Statue of Liberty. You're good. It's going to have the same shape. It's going to have a lady on a rock. What she got? A book and a torch, right? She's going to have a crown. It's not going to be the same size, but she is going to be similar with the same shape but a different size. Now, when it comes to polygons, we're going to have corresponding, which basically is a word that just means matching, right? So if we're going to have matching angles, these are going to have to be congruent. Okay? If you want to think about this in less long math words, matching angles same. So your matching angles need to be the same. The exact same. That's what congruent means. Now, your corresponding sides, which have lengths, are not going to be required to be congruent. Because if you have the same angles and the same sides, then you're just the same and you're congruent. Our shapes are not going to be fully congruent anymore. Our shapes are now going to be similar. So these are going to be proportional. Another word straight off the quiz we just took. The ratio is going to be called the scale factor, right? So if I have a Statue of Liberty on my desk, it might have a scale factor of, I don't know, something like 1 to 1,000 or something, because it's going to be 1,000th as big. You know, I don't really know how big the Statue of Liberty is. And just like a little fun point, right? This isn't like, all of this stuff is kind of like big, important stuff. This point is just like a little fun point. If polygons are similar, then their perimeters are also proportional. And that might sound complicated because perimeters is a word that can make things sound more complicated, but we already know that the sides are going to be proportional. So if the sides are going to be proportional, the perimeter is just add up the sides. So obviously, if the sides are proportional, when you add up the sides, it's still going to be proportional. So let's see that happen. Okay, we got two triangles here, ABC and DEF. We've done lots of questions with two triangles. We've done lots of congruent triangles question. These questions do not say anything about congruent. They don't tell us that ABC is congruent to DEF. And if you look at this, we do have these congruent markings, right? We have 1 matches 1, we have 2 matches 2, we have 3 matches 3. And so what we have in theory here is AAA. It's not SSS, it's not, SA. We don't have any sides. What we do have is all 3 angles. Now, we learned this. Was AAA a possible option for congruent triangles? No, because AAA does not guarantee that you're congruent triangles. If you look here, these are the same angles. Do we have any matching sides? No, we don't. So these are not congruent. Again, our brain gets a little frazzled because we're thinking about, ooh, congruent. These are just supposed to be similar. So what is the scale factor? That means we're trying to figure out, like, A is different from D. How different? Is it twice as big? Is it 3 times as big? Is it 1.5 times as big? So we're going to look for matching pieces. For example, I see that A matches up with D. And then we're going to look for corresponding sides. So, for example, if I see that, 8 right here, which is a corresponding side in the other triangle that matches up with 8? 12. It is 12, right? Across from the C is the same as across from the F. So 8 and 12 are corresponding. Now, I'm going to figure out this scale factor. Which triangle do they mention first? They mentioned the ABC triangle, so that's the number I have to put first. I'm going to put the 8 and I could use a colon or I could use a fraction. I want to try to simplify this fraction, so I'm going to use a fraction. That way I can see if this does simplify. On triangle ABC, it's worth 8. On triangle DEF, it's worth 12. So let's try Desmos. Here we go. Let's try simplifying this. 8 divided by 12. Hit the fraction button. 2/3. So that is the scale factor. That means that ABC is 2/3 the size of DEF. It's not quite as big. Now, I just want to prove a point to you really quick. Let's pick a different corresponding side. Let's pick this 14. Which one corresponds with 14? 21. And if we make a fraction here using the ABC one first, so I'm going to use the 14 first, 14 over 21, you can probably do this in your head. That's going to be 2/3 as well. It's the same thing. You don't have to check every single one because no matter which ones you pick, thank you for getting the door, Jazzy. No matter which ones you pick, they're gonna be all the same. So we get 2/3. Now, what is the scale factor of DEF to ABC? It sounds a lot alike. Is the answer gonna be 2/3 again? Not quite. It's going to be very close to 2/3. If ABC is 2/3 of DEF, it's a little bit less. DEF, we cannot say that DEF is also 2/3 because that means that DEF is also smaller. We're going to have to flip that fraction upside down. Because they say DEF first, that's like if we started here with the 12 on top of the 8, then we fraction it, or then we simplify it, and we're going to get 3/2. So if you have a bigger triangle listed first, your number should be above 1 because it should be larger. If you have a smaller triangle listed first, your fraction is going to be less than 1 because it's going to be a little smaller. Now, what about the ratio of the perimeter? Now again, this is just like a fun little party trick, right? DEF has a perimeter, which means add up all the sides. And the DEF is listed first, so that one goes on top. 12 plus 15 plus 21. And then ABC comes second. That would be 8, 10, 14. And we're just adding them up because we're doing the perimeter. I'm going to go to Desmos and type this in. Fraction button first. Then I'm going to press 12 plus 15 plus 21. On the bottom, 8 plus 10 plus 14. And guess what I get? The same exact thing again. If the sides have this proportion, when you add up all the sides, you're still going to have this same proportion. So we're going to have 3/2 for the perimeter, as well as 3/2 just for the individual sides. Okay? So, how do you say that these are the same? We can't use an equal sign. We can't use a congruent. These triangles are not congruent. This one's bigger. So what we do is we write triangle ABC, triangle DEF, and we're going to use just the squiggly line. It's like a congruent sign, but there's no equals there because these are not actually equal to each other. right? The 8 is not matching up with the 8. There's another little box over here. I don't think that's super important, but that's what symbol is supposed to go there. So when you see question number 1, it says that triangle JKL congruent to triangle PMN. All right. I think I said congruent, but I didn't mean that. Triangle JKL is similar to triangle PMN if I accidentally said congruent. That's my bad. The same thing as the congruent triangles, you really want to start out, draw those curves in there. It makes things so much easier. These have to be in the correct order, so that means that J comes first, it can get one curve. P comes first, it can get one curve. K is second, M is second, L is third, N is third. Now it becomes very, obvious which ones match up. Now when it comes to angles, I know it's a little loud in the hallway, we still got 2 minutes before lunch. Angle J and angle P, tell me about angle J and angle P. How are they related to each other? Are they equal, similar, congruent? So, how is J related to P? Are they equal, similar, or congruent? Remember, the angles are congruent. We don't really use the equal sign when we're talking about shapes. So, we're going to use the equal sign with the congruent. The angles are exactly the same. The angles have to be the same. Not similar. There's really not really such a thing as similar angles for now, at least. Okay? Your angles are congruent. Then if we look at K and M, those are congruent. If we look at L and N, those are congruent. The angles have to be the same. Right? I just wrote same underneath there to be close. Now, the sides, are the sides going to be identically the same? No. These are going to be proportional. All right? That means these are going to set up into that fraction kind of thing. Now, this is a little bit strange looking, this side setup. But basically, we're going to say that this first side, which goes from J to K, side JK, if we divide that by the first side of the other triangle, which is P to M, that's going to give us a ratio. And that ratio is going to be exactly the same as all the corresponding sides. So if we look second at the KL side, that's going to be proportional with the MN side. I know this looks a little crazy, but there you go. All right, lunchtime. Go to lunch. Nice job.